Now, I have no idea how this segment will actually come out, because the original recording was upside down, but I didn't really want to repeat the entire signal again because it's 4 minutes and I have a slight problem with this timer relay here, by which if I repeatedly test it, etc., the relay will actually bind together. Now, I don't know whether this is going to be a prolonged issue. I haven't actually tested it on full volume because it's loud as anything, but still, if it does encounter problems, I can always switch it out for a larger relay, although it's going to be incredibly finicky. As you can see, space is at a premium, and that's mainly because I didn't actually realise that I was going to have to cram all of this stuff in here. If I had more money in vouchers, etc., so free money, I would be able to buy 2 of these enclosures equaling £30, and I would be able to do all of this. So this is around about 15. This was free because I already had it, and so was the rest of this, but this and this and this is basically the main costs for this. So basically, this is how it works. You have this rather brightly orange safety cable going in. I designed it that way, even though I have this lying around still. Safety cable goes in here, and then it enters this double socket. This double socket here then distributes power to these 2 plugs. This one is the main 9-volt power supply for all of these small electronics here. This is the big 230 volts / 250 volts peak going into this power supply here. This generates 24.16 volts as adjusted at the potentiometer down there by that green LED. And this basically rectifies the 24 volts DC from the 230 volts. It's a switch mode power supply, so it is incredibly efficient for its size. At least I'm told. I haven't actually done any things, but there are plenty of reviews on this by proper certified electricians and electronic specialists, etc. So it's better bet to trust them and not me. Still, this does its job particularly well so far. So this is how it basically works. You have this main cluster of electronics here. So this grey timer here is the amplifier timer. This has a slightly, how do I put it? This has a slightly slower response time when it's being triggered. This is just because it's a different type of microcontroller and it's a different board type. However, these all work up the same basic architecture because in China, patterns don't really exist. Well, I guess they do in China, but no other foreign patterns exist, as I know through hard experience. So down here, there are 2 timer boards, that's for 2 signals. So this one is Whale, which is the second one which I did. That has the standard 3 seconds on and then 4 seconds off. That's mimicking several North American Siren models of different types. And then the one down here is just complete steady signal for 2 or so minutes. This is time to 124 seconds, and this is time to 126 or 128, I forget. The video will tell you anyway, not me. So this right here is the main brains of the entire thing. This is the actual tone generator. You can buy this for around about $10 at Cheney Electronics. I do warn you though, you're going to have to buy something else as their minimum order price is $15. Shipping to abroad in the US is incredibly expensive given their shipping choices, and so it's not a particularly economic thing. That is unless you have relatives in the continent, which I do, so I'm kind of at an advantage, but these are incredibly powerful for what they are. The switch on this has been modified to be 2 particular leads, which then go into this common terminal block here. Similarly, the speaker out here then just goes straight into this amplifier board here, and the main power in are these 2 leads here. If the camera was pointed the correct way, I forget, but this particular lead here, which is trimmed, this was the ground, because when this was originally in a metal case, it induced feedback, and therefore I had more of a pulsating tone and a lot of interference, which was not good at all because I want the pure sound wave, and the speakers want it too for their longevity. So these boards do all of the timing for the signal itself. This board times the amplifier, and these both basically work in tandem and they're both timed to the same thing in order to mimic the correct sort of coast down time. It's not actually necessary, but for the sake of authenticity with other designs, I decided that I would time this to longer, so around about 126 seconds, 128 seconds as described earlier, primarily because then it allows the amplifier to display, well, to sound the wind down, coast down, pitch drop, etc., whatever you want to call it. One size fits all, basically. So this main terminal brick here, it's all a bit of a mess, and I should probably clean this up, but since it's not broken, I'm not fixing it. But this chocolate box terminal block here supplies the positive from this particular power supply here, and this is the positive that then goes into this main timer here, and then the timer below is daisy chained off of this, and this does the exact same thing. This is daisy chained off this, and this is basically because this only has a finite amount of connections you can make before you just can't physically fit stuff. And also, I didn't really design it in mind where you would actually have room. I've got more room here, which is quite small-minded of me. I should have moved it over a couple of notches, because this you don't have to service as much, this you do. So this main terminal block here is negative for all of the things, and also the trigger lines for all the respective components. So this orange lead going out here is just a temporary wire. This is where I would put the steady trigger in, and then the other one just goes over to positive right here. So this trigger then triggers the steady, and that goes all the way down to the respective timer down there. And then this terminal brick here will then trigger the whale, and so this yellow cable and this shielding then connects to this push button here, and I've also activated it, which is quite annoying. So what I'm going to do is just turn it off, and then that should ease the load in this. I should have realised, but oh well, it doesn't particularly matter. And there's also a rather helpful thing with this particular board, is that the LED will actually tell you when it's on. It doesn't actually tell you when it's powered on, it just says that power is present. I don't know whether that's actually a design fault, but since it was a low-cost Chinese amp, anything can basically happen. Now, when this is at full power, the discharge of the capacitors is always going to be less, as in time, because it's going to be using more of that power more quickly, and therefore it's going to be using more power. And that's why I've adjusted this, so it takes a certain amount of time to actually do it, to actually turn off. And that's purely because such a thing with this happens, and that's just because the capacitors are going to discharge quicker because it's running at full power and therefore demanding the highest load. So these are the two triggers here, and this terminal brick here is purely because I have a diode going in here. This is purely just because I don't want any feedback going in. And here I have another diode, which is basically preventing, because diodes are basically check valves and they're ohmic components, this diode here prevents any voltage from going back and then triggering the steady. Because before I had a jumper going straight across, and realistically I was on the correct track, but I wasn't actually, instead of the jumper I should have put a diode in, because every time that I triggered whale, it would still stand in steady, because all of the timers would be going at the same time, and therefore it defeats the purpose of having two timers. It just doesn't work. So this goes into its own common reference point right here, and in an ideal world I would have had all of these in their own respective ordered terminal lines, but since I didn't have space, there was no point really. And as you heard, it made this muted noise, meaning that it didn't actually turn off. So when I do that, it should turn this LED off. It sometimes doesn't agree with me. There we go. So you just have to turn this off to discharge it. Now the speakers which I'm using are these. This is just attached to a horn. It's a 35mm thread 100 watt compression driver. You can get one of these for £14 or whatever your standard currency is. But there we go, if it would actually focus. So yeah, it's just a 100 watt 8 ohm compression driver. It's actually meant for a tweeter, a tweeter compression driver, but it still works on these frequencies. Its longevity will definitely be decreased, that's for sure, but still, it works. And this amplifier here is a 200 watt power amplifier, so it's 100 plus 100, so right and left respectively. It runs on 24 volts to get this 100 watts. If you ran it on 12, it would only produce 50, and so on. It's sort of this sort of wattage ambiguity that would get certain people, how would I put it, misguided, could you say. This is a switch mode power supply that is universal for all of the world, so you would actually switch if you were in the US, etc. And it has a rather wide tolerance of voltages, so these are just purely references. I'm on 230 volts and most of the US will be on 120. Some will be on 110, but of course my knowledge of over there is really limited. So as I've said, all of this goes over to here, and this amplifier timer here basically takes the positive leg out of here, so that's this red cable, goes straight into there, and that's your common, that's in the middle of the relay, and then the orange then goes straight out into this terminal strip over here. And this terminal strip really is just to connect all of your things. Now I have modified this slightly. There used to be a set of RCA jacks, and I actually traced to see what lines were which. So the main RCA jacks were just left and right, and then I sourced a ground from the additional stereo input, which is that white box there. The centre pin on that white box is the thing. And since this is designed for cars, it will have multiple sort of input choices, and there are several unused solder points on there, as it is a sort of general pattern part board. Now this is an IP66 rated box. Because of the holes that I put on the side, it's probably now IP65. The IPXX stands for, the first X is basically, I should say IPXY, so the X stands for dust intrusion, and then the Y stands for water intrusion. So although this will be fully dust protected still, it will still let in water to some degree after prolonged exposure. So I should really button that down and probably silicone this instead of using hot glue, but still, the thought is there. And on the subject of hot glue, I don't particularly like to do this because it's going to fall off at some point and it's not going to cause damage because it's all electrically insulated, but still, on that particular note, it's not always a good idea. These are all stuck down with hot glue as well, and I wish that I didn't do that, but you kind of don't have any choice because you can't widen the holes to put Meccano bolts or stuff in there, or any sort of M6 screw, because they're so close to the borders. As you can see down here, they're so close, if you try to widen them, it will just completely obliterate the corner of the board. And this one doesn't even have any screw holes whatsoever, which is even more annoying basically. So that's basically the things which you have to consider. But all in all, if you have some electronics knowledge and you have a soldering iron like that one over there and basic stuff like that, you will be able to get your something similar to this working. And since this is rather universal in design, you just need to get your own region's versions of power converters down to 9 volts for this and down to 24 volts for this, and you will have your 200 watt speaker array running in no time. Now I've designed this particular speaker array, as you can see. It has this particular horn which has a very good resonant frequency. It is a glass fibre horn, so it's going to be outside. It's meant to be located in a speaker cabinet, but there's several sort of Chinese companies making these, just of different brand names, but it's basically the same picture and it's the same horn device. They just sell them for different prices, so if you get the lowest priced one, they're all £1 postage or whatever your standard currency rate is at the moment. It's all relatively cheap postage to your region of choice, and although it's snail mail, I mean properly slow, as in a container ship, it still will be a very good option. And this will also help propagate your sound because of how sound waves, etc. work being longitudinal waves. So that's basically how the entire thing works, and hopefully this will be useful to someone. Might not be, but then again, that's that's basically what this channel is about, stuff which isn't useful to people except me. So yes, this is basically how it works, and hopefully this will be the last revision. Probably won't, but oh well. As the evolution of everything goes, you can always make improvements.